find yourself doing the same calculations over and over and over again, you may decide you want to go the computational physics route. Open up your favorite spreadsheet, Google Docs or Excel, and enter your data table. Take some time, color code it so you can see what you're doing, put in labels so you don't actually put the wrong number in the wrong place. In this case, when we're colliding two carts, we'll need one entry for the mass and two entries for the velocity, one for before the collision for each cart and one for after the collision for each cart. Lay out your data table, enter your data, and then we'll be ready for some formulas. To find the total momentum, you want to multiply the mass times velocity of each cart and add them together. We're scheduled to do this over and over and over again, so why not have the spreadsheet do it for us? To start a formula, type equals. Equals is code for here, there, be formula, don't take my typing literally. To start off with, click where you want to click. First mass, times, yes, you have to put the time signal in every single time. Next to does not work in computers or spreadsheets or calculators. Velocity, there we go, plus mass times velocity. As I said, click where you want to click. The reverse is also true. Do not click where you don't want to click. If you're done, do not click. Do not click anything or it will go into your formula. Take your hands off the mouse very gently and press enter. There, total momentum. It would be very nice if we could copy this formula, total momentum, and paste it here, total momentum before, total momentum after. Alas, if we do that the exact way we have typed, it will not work. Let's proofread and see why. Second lesson in computational physics. Here we are, our new cell. It says B3 times B4 plus C3 times C4. Let's proofread. B3, that's velocity, times B4. That's wait a minute, we shouldn't be multiplying two velocities. There are two ways to enter a cell in Excel. One is just like this. This is a relative reference. It's one cell over and three cells to the left. There's also an absolute reference, and these masses over here are absolute numbers. This is going to be the mass of cart 1, and this is going to be the mass of cart 2 for the entire lab. If up here we really want B2 and only B2, say column B, you know the one over here, 3 over, but I mean cell 2. And I always mean cell 2. The way to include an absolute reference is with a $sign. If you're deucedly paranoid and you're worried you're even going to get the column wrong, you can say an absolute column reference as well, but that's seldom necessary. Notice we get the same thing here, but when select over here we fill down or control D, now we're going to get a very different number. Now we're going to get B2 times B4, that's the mass times the after velocity, plus C2 times C4, the mass times the after velocity, and that was what we wanted. If we want to do something similar for kinetic energy, notice, again, take the time, make a data table that you can read, color code it, you'll be glad you did later. We can put in another formula. Equals, there's our formula, 1/2 m, now we know to click in here and make this an absolute m, times, don't forget the times, v squared, plus 1/2 times m, absolute reference. Remember, don't click. Use those arrow keys to navigate around. Times, there we go, v squared. And that we ought to be able to control D, fill down nicely. Next up, percent error or percent difference. Again, make your data table, make it nice, and put in a formula now to save yourself work later. Both of these are lab measurements. Both are equally suspect. It's not safe to say that the total momentum before was measured perfectly, and all errors are due to a change afterward. Use the laboratory formula for percent error. You want formula, the difference between your first value and your second value. value divided by not one or the other, but the average between them. This one plus that one, all over 2. If you want to make that a nicer formula, you may. In any case, use the color codes to make sure that all your parentheses are where they should be. And you'll see that you're getting a certain percent error. Copy the formula, and you can use the same formula over here. Ooh, check those cell references. Sure enough, it is the percent difference between F3 and F4, our kinetic energies. There are our percents error. And now we can take a look at how good our data is. We're getting 225% error for our total difference in momentum. Why so big? Because these numbers are so wretchedly small. Look at that. When we add them together, we're getting less than we started with because one of them is negative. We're getting a much more respectable 42.2% error for our kinetic energy. Does this look like good data? Well, it's a big margin of error. More importantly, look at the totals for momentum and energy. This appears to be trying very hard to be 0. This appears to be trying very hard to be 0. We can understand if you're trying to divide by something that's supposed to be 0, the percent difference is not going to make a whole lot of sense. We'll go over different models for percent difference in a little while. However, if you look at the kinetic energy, you'll see that it markedly increased over the course of the collision. This is violation of conservation of energy by 42.2%. That's not small. What does that mean? It means one of these velocities over here was not measured correctly. So if you're doing this on a spreadsheet on your laptop in class, now would be a good time to retake your data, especially if it turns out that you read the slope wrong, knocked over the motion sensor, or that was the time somebody sneezed and threw off your data, and this was actually supposed to be 0.74 and not 0.63. Aha! That's bringing our numbers down out of the rafters. Still has an increase in kinetic energy. That means something is violating physical law. Still worth retaking the data. Once you've retaken your data and gotten accurate speeds, God willing, don't stay up all night. If it's 8:30, go home already. Then you can see your percent errors coming down out of the rafters into something more reliable. If you're sick and tired of looking at these decimals, note that you can always say, I just want the positives. Leave the negatives out. Absolute value, please. And while we're at it, real percent, and you can see your percent error come right out. That looks like a perfectly elastic collision. You're only losing 0.41% of your kinetic energy. Once you've got all your formulas down, you can, if you're keeping all your calculations, make multiple data tables with new values and just watch your totals change. Good data, bad data, typo, accidentally entered your old data in your new data, your percent difference will instantly show you. If you find this saves a lot of time from typing everything into your calculator, enjoy and Godspeed.